Hey everyone, welcome back to Science by Asha Madpa. Today I will be starting up with the class 10 syllabus and I will be teaching you chemical reaction and equations. But before I start my session, I would like to request you all to kindly subscribe to my YouTube channel and share its link among your friends and family. So let's begin today's class. Now, the name of the chapter is Chemical Reactions and Equations. You must be familiar with the term reaction from your lower classes. You must have heard this name in the topic of photosynthesis, right? But there is more to this topic, chemical reactions and equations. So basically in this whole chapter we are going to understand about the chemical reaction, chemical equation, the various types of the chemical reactions, and in the end we will be trying to understand few chemical reactions from our everyday life. So let's begin today's class. Now, before beginning the main topic, we will recap certain uh, definitions which you are aware from class 7th onwards. So let us begin. The first term is physical change. Now, physical change is a change in which no new substance is formed. This is a change in which no new substance is formed. Basically, whatever we are seeing a change in the physical state. Nothing chemically is changed inside the material. So the definition itself says that these are the processes in which no new chemical substance is formed and they are called as physical changes. Now, if you take the example of melting of ice. Now, when ice melts, it gives you water, right? And if you will freeze this water, you will again get ice. So what is happening here? There is a change in the physical state, that is liquid to solid and solid to liquid, right? There is nothing new which is getting formed. There is nothing totally different is getting formed here. So it is a physical process. If you take example of the dissolution of sugar in water, that is mixing of sugar in water. Suppose this is a beaker and in this beaker you have added salt and water or sugar, okay, which I have written in the example. You mix them, you will find that the particles of water and sugar or salt are still there. They are not forming anything new. They are still present inside the beaker or the glass in which you have mixed. So they have not combined together to give you something new there. Okay, so it is again a physical change. It is a process in which nothing new is getting formed, and you can separate salt from water easily by the technique of evaporation. Sugar also you can separate from the water easily, okay, using any of the using any of the physical methods of separation, right? So basically in the process where we are seeing that nothing new, no new chemical substance is getting formed, those processes are called as the physical processes. On the other hand, there are certain processes in which we see that new substance is formed which is entirely different from the things which were present at the beginning of the chemical reaction or at the beginning of the process. So processes in which original substance lose their nature and identity to form new chemical substance with different properties is called as a chemical change. For example, if you see burning of fuel here, let us take the example of petrol. You all know that it is a very thick kind of liquid, but when petrol burns, it gives us what? It gives us carbon dioxide, right? And along with this, water vapors are there. Now see, water vapor and carbon dioxide are completely different from petrol, totally different. So here something new is getting formed. So this is an example of a chemical change. Similarly, if you see rusting of iron. Now iron is black in color, grayish black in color. So it reacts with water and air, or sometimes we say that moist air, and it forms rust. Rust is what? Rust is a brown powdery substance, and iron is what? Iron is a grayish black substance. right? So here also you are seeing that rust is entirely different from iron. Okay, so here also something new is formed. So this is a chemical change. Now the chemical change are itself having the chemical reactions to them. So the process involving a chemical change is called a chemical reaction. So chemical reactions are basically the chemical changes. Okay, so let us try to understand few more terms related to the chemical reaction. Now, what are reactants and products? Reactants are simply the materials which are present at the beginning of the chemical reaction, and all those things which are formed at the end of the chemical reaction, they are called as the products. So here also the same thing is mentioned. Chemical substance taken originally are called reactants. The new chemical substance formed during a chemical change is called as a product. So anything which was present at the beginning of the chemical reaction, that is called as the reactant, and all those things which are present at the end, they are called as the product. So here also you can see that A plus B, when combines, it gives us C and D. Now there is a plus sign, that is two reactants were present at the beginning of chemical reaction. Okay, so A and B are reactant here and C and D are product. So two products are formed. Whatever product or whatever number of products are formed, they are always having a plus sign between them, just like in the case of the reactant. The arrow always points towards the product. The point of the arrow should be towards the product. That is, the arrow points us that what is formed at the end of the chemical reaction here. Right, so anything which is present at the beginning, that is called as a reactant. Whatever is obtained at the end, they are called as the product. Okay, and in between you will have to put a arrow sign. The arrow must point towards the product. So reactants are present at the beginning and products are the materials or the new substance which are formed at the end of a chemical reaction. Now let us start with few common examples of chemical reaction. You must be familiar with them from your lower classes. So chemical reaction, first one is burning of magnesium ribbon in air. Now see, magnesium ribbon is there in the labs. You can observe in your school lab. Now this magnesium ribbon, when you will be seeing it in the lab, you will be seeing that a white powdery substance must be over to it. Okay, now this is a magnesium ribbon, and you can say that from where this white powdery substance is coming over to this ribbon of magnesium, which is a metal. Now you know that it is a metal, so obviously it is reactive in nature. So what happens is that when magnesium ribbon is in lab, it slowly reacts with the moist air. Okay, it slowly reacts with the moist air and it forms a white powdery substance over to the ribbon. This white powdery substance is magnesium oxide. So before beginning this experiment, we always rub the ribbon with a sandpaper. Why? Because sandpaper is rough. Its surface is rough. So when it is rubbed over to the ribbon, or the piece of the ribbon, it removes the oxide layer, the magnesium oxide layer, and you get the fresh surface of the magnesium for the experiment. Okay, so actually it is rough in nature, so what will happen, that rubbing of the sandpaper exposes, rubbing of sandpaper exposes fresh surface of magnesium for experiment. That is why the step is done. So what will happen, you will have to take the piece of the magnesium ribbon and you will have to hold it with a tongue, otherwise your fingers will burn. Okay, hold it with tongue and you will have to put it over to the burner. Okay, the flame of the burner, okay, and then it will burn, it will catch fire, it burns with a very white dazzling light, and you will have to keep a petri dish below to it, and whatever is getting formed, a white powder will be formed and the residue will fall on this petri dish. Okay, so this residue is actually the magnesium oxide. Same thing is written here. Magnesium ribbon burns in the air to form magnesium oxide. When the magnesium metal burns, it reacts with the oxygen found in the air to form magnesium oxide. Oxygen and magnesium combine in a chemical reaction to form this compound, and at the end a white powder of magnesium oxide is formed. So how we are writing it here? In the beginning, magnesium is present, you have brought it over to the flame, okay, where it reacts with oxygen. So magnesium and oxygen becomes reactant here. They were present at the beginning of the chemical reaction, and at the end of the chemical reaction you have obtained a white powdery substance which is magnesium oxide. So this is the product here, right? Now let us go to the another chemical reaction, again a very simple one. Okay, reaction with zinc and dilute hydrochloric acid. The okay, now the symbol you must have seen it in the lab. In the bottle DIL is written. So DIL means dilute, that is some part of the pure hydrochloric acid is mixed with the water. Okay, HCl is the symbol, okay, over to the bottle. Now the reaction between zinc and hydrochloric acid. So what is usually done, that we take a conical flask. Inside the conical glass we take little bit of the hydrochloric acid, that is HCl, and we drop few shavings or very fine pieces. Okay, drop very fine pieces of zinc. Now as soon as we will drop few very fine shavings or the pieces of the zinc, you will observe some bubbles are coming out and little bit of the sound, hissing sounds like that will come out. Okay, proving that there is some gas which is getting formed, okay. So basically what happens inside the conical flask is this, that you have added the pieces of zinc and hydrochloric acid was already there. So these were the two reactants in the reaction. Okay, they combined and they form hydrochloric acid which was there inside the beaker, and hydrogen gas is formed. So this gas you were observing in the form of small bubbles, and there was a hissing sound which was coming, right? So these are formed at the end of the reaction, so they are called as the product. So product are zinc chloride and hydrogen gas. Let us check it. In a conical flask, add dilute hydrochloric acid. Now add few pieces of the granulated zinc into it. You will observe that a gas is evolved. The evolved gas is hydrogen gas. So zinc and dilute hydrochloric acid combines to give us the zinc chloride and hydrogen gas. Now how you can identify that this gas which is evolved is hydrogen gas and not carbon dioxide or the oxygen gas? So what we do for the identification of the hydrogen gas, when you have dropped the zinc pieces inside the conical flask which was having the hydrochloric acid to it, and when you are seeing that bubbles are getting formed and there is a hissing sound which is coming, you will do what, that you can bring a burning candle near to it. A lighted candle you will bring near to the mouth of the conical flask. If on bringing a lighted candle near to the mouth of the conical flask, you will hear a pop sound, and the pop sound is followed by extinguishing of the flame, then you will say that this is a hydrogen gas. Because if it is a oxygen gas, then the size of the flame will increase, because oxygen helps in the support of burning. Okay, it helps in burning, and carbon dioxide gas always extinguishes the flame, that is it will stop the burning process. But here you will observe what, here you will be hearing a pop sound, okay, and which is followed by the extinguishing of the flame. So this is a characteristic of hydrogen gas, and thus it confirms that hydrogen gas is evolved and the zinc chloride which will be formed, it will be inside the flask. Okay, now let's move towards the next topic, that is the characteristics of chemical reaction. Now how can we say that a chemical reaction is like it has happened there? There are few things which we can observe from our naked eyes, although obviously in a chemical reaction there are changes which are occurring chemically, that is inside the substance, the various things are getting combined and so on, but there are certain things which we observe from our naked eyes, and even there are some points which we can feel also. Okay, so first one is the formation of precipitate. If after mixing A and B you are seeing that in the product you are getting few curd kind of particle, that is the curdling. Like suppose you are mixing small amount of the curd in little bit of the water and you mix it, okay, that kind of thing, if you are seeing that they are getting formed at the end of a chemical reaction, then it is called as that there is a formation of precipitate in the product. Okay, so if we are observing the curdling, okay, then there is a formation of precipitate. Basically precipitate is a more scientific or a more better term of the curdling here. Okay, so if we are observing it, then we can say that yes, a chemical reaction has occurred. Similarly, evolution of gas, like in our previous example, when zinc pieces were dropped in hydrochloric acid, we have seen the formation of the bubble along with the hissing sound. Okay, so that is, yes, we can say after that that yes, there is a chemical reaction which has occurred. Then there is a change in the color. Sometimes we observe that there is a change in the color. For example, the formation of rust. Rust is brown in color, but iron is grayish black in color, right? So there is a change in the color of the product. Then there is a change in the state, like for example petrol. Petrol is what? Petrol is liquid in nature, but what it is forming? It is forming carbon dioxide gas along with water vapor, right? So there is a change in the state. Then there is a change in temperature. Okay, sometimes what happens that if at the end of the chemical reaction we touch the walls of the container can be a beaker, container can be a test tube, it can be a conical flask, and if on touching the walls of the test tube, conical flask or the container you are feeling that it is little bit warm, then such kind of reactions are called as exothermic. And if you are feeling that the walls are little bit cold, okay, then it is an endothermic reaction. So there is a change in temperature which can also give an indication that yes, a chemical reaction has occurred. Now see here the exothermic reaction definition: reactions which are accompanied by rise in temperature are those in which heat is evolved. Such reactions are called as exothermic reaction. For example, in the previous one, like zinc plus hydrochloric acid. Okay, in this reaction also, if you will touch the walls of the conical flask, you will feel that the walls are a little bit warm, proving that it is an exothermic reaction in which the energy is evolved or the heat is evolved. So it is forming what? Zinc chloride plus hydrogen gas. Okay, so this is a chemical reaction in which at the end of the chemical reaction, when you are touching the walls of the container, the wall is little bit warm, proving that heat is evolved at the end of the chemical reaction. So such reactions are called as exothermic reaction. There are a lot number of reactions which are exothermic in our surrounding. Now endothermic is opposite of the exothermic reaction. Endothermic reaction is a reaction in which heat is absorbed. Okay, it is not evolved. So reactions which are accompanied by fall in temperature, that is when we will touch the walls of the test tube or the beaker or the conical flask at the end of the chemical reaction, then the walls appears to be little bit cold, they are not warm. Okay, so those reactions are called as endothermic reaction, meaning to say that they have absorbed energy, they have taken energy inside it during the chemical reaction. Okay, so these are some characteristics which helps in identification of a chemical reaction, that whether a chemical reaction has occurred or not. Now moving to the next topic, chemical equations. Now chemical equations are basically the chemical changes or the chemical reactions itself. Now the chemical reactions can be written in two ways. Okay, the first way is a word equation where we write the full word, like zinc reacts with sulfuric acid, so we will write ZINC, zinc, add symbol, that is it is mixing or it is getting combined. Sulfuric acid, the whole letter is written SULPHURICACID, acid. It gives us zinc sulfate plus hydrogen. So we have written it in the form of word completely. Okay, rest of the things like arrow we have made to show that yes, a product is there. We have also put the plus sign, which is the addition sign there. All those things are there. Okay, so this is a word equation, but we cannot write word equation always. First of all, writing a chemical change or a reaction is itself, like we cannot keep on writing the full sentence, zinc reacts with sulfuric acid to give us the zinc sulfate and hydrogen. So to short this whole paragraph, what we have done, we have picked the main words from there and we have shown with the help of those words the reactant and the product. So this is the reactant side, this side zinc plus sulfuric acid. Okay, but in this step also the writing is too much, like you will have to write the whole name of that particular reactant and the product. So to shorten this process, we use the symbol and the formula. So when we are writing it using the symbol or the formula, then it becomes chemical equation. Like here, the zinc ZINC changed to its symbol Zn, sulfuric acid symbol H2SO4, and the product ZnSO4 plus hydrogen. Okay, so when we are writing the chemical reaction in the symbol or in the formula, it is called as a chemical equation. So a chemical reaction in terms of symbol and formula of the reactant and the product, it is called as a chemical equation. So chemical equation is simply a chemical reaction when it is written using the symbol or the formulas of the reactant and the product. So that is a chemical equation. Now we will try to understand more about the chemical equation. There are few things which are associated with it and which needs to be learned. So that topic I will be taking up in my next session. Till then, bye bye, take care, and please subscribe to my YouTube channel and share it among your friends and family. Bye bye.